This example will be in this problem we'll be using the either the root test or the ratio test, but clearly, so first let us write the series. The series is sigma from n equal 1 to infinity of 2n plus 3 to the power 2n over n squared plus 1 to the power n. So since we have power 2n and power n on the top and bottom, here it will be a wonderful problem or series to use the root test. Using the ratio test can be done, but it's very complicated. I mean, a lot of algebra. So here what we are going to do, we are going to use the root test. So here definitely we're going to use the root test. For that, let us write all this as an. So we write an equals 2n plus 3 to the power 2n over n squared plus 1 to the power n. And now we take the nth root because n is positive. There is no need for the absolute value. So here is an to the power 1 over n, which gives me 2n plus 3 to the power 2n over n squared plus 1 to the power n to the power 1 over n. So now we have to be extremely careful about algebra, and for that we have 2n plus 3 to the power 2n to the power 1 over n divided by n squared plus 1 to the power n to the power 1 over n. And now, whenever you have a power to a power, you multiply the powers. So this gives us that the root of an, the nth root, equals 2n plus 3 to the power 2n times 1 over n. And at the bottom we have n squared plus 1 to the power n to the power 1 over n. So we cancel the n's from the power of the top and the bottom to get 2n plus 3 to the power 2, because it was 2n over n. And at the bottom equals n squared to the power 1. So now we need to find the limit. So we have at the top 2n plus 3 to the power 2. Let me develop it completely. I mean, I can use many ways to find this limit. So, but if I develop it, there are many ways, okay? So here is 4, I'm using 2n squared, which is 4n squared, plus 2 times 2n times 3, that's 12n, plus 3 squared over n squared plus 1. So now you see that the top goes to infinity, the bottom goes to infinity. We can use the operator root-wise, or we can just say that since this is an expression of a rational expression of n, powers of n, so we just keep this one and this one when n goes to infinity. So the limit of the nth root of an when n goes to infinity is the same as the limit highest power or monomial over n squared when n goes to plus infinity, which gives me 4. But we can do different ways. I mean, there's no one way to do this limit, okay? So we see that 4 is bigger than 1, therefore the series an is divergent by the ratio, the root tests.